All right, so let's get started, guys. Okay, so today the first, first lecture, first session of the networking fundamental, right? And as you see here, the approach would be, we would show the network diagrams, right? Simulations and other live demonstrations as well. Okay, what you will learn in this particular overall course, whether it is CCNP, CCNA, or CCI. Okay, when we talk about this enterprise, you see in this you will learn the network fundamental. Okay, network access, which is network fundamental, which is switching, as well
Switching.
as the basic networking concepts like networking equipments, right? OSI model and other architecture of the network topologies, right? And then network access, where it is all about the wireless and wireless security. IP connectivity is for like layer 3 IP protocols, routing protocols. IP services are day-to-day services that we use in our network. For example, DSCP, most of you know, DNS, right? NTP, TFTP, SNMP, all those services, HTTP, right? Security fundamentals, how you're going to secure your network, right? And then a bit of automation as well as and programmability. Okay, so let's get started with this and understand what is network and how you're going to what you're going to learn in overall this session, right? Apart from this, we'll also ensure what all components that we use in network and
I,
what
I think nothing. I'll call you later. I'm in the class.
you guys can mute yourself. One moment, just give me a moment. I need to add one more guy here. Where is that badge? Sandeep is the part of it. Right? Yep. So by looking at this diagram, first of all, what do you think? These are the devices, not only this, but the other devices as well. Okay, you will have in the network. Okay, but primarily, yes, I would say you will have laptops, you will have desktops, you'll have printer, isn't it? PlayStations, smartphones, desktop. Apart from these, what you would have is IP phones for the collaboration. You will have the servers. Servers also would be deployed. Now the servers, when we say that can provide any services, you can have a DHCP server, you can have a DNS server, you can have a TFTP or FTP server, right? And you can have a HTTP server. So anything, but this is again the part of the network, isn't it? You will have routers, you will have switches, right? You will have access points as you see here. So what is network? Basically, it consists multiple devices exchanging the data, right? NIC card, this is what actually the NIC card we have. And if you remember, we were talking about the NIC cards. Why NIC card is there? When we talk about the types of network, we have wireless and wired network, right? If it is wireless, then you will have a wireless adapter, Ethernet adapter, isn't it? If it is wired, then you will have a NIC card, the wired NIC card. Then this is where you will connect. You see this small black one. This is where you will connect the RJ45, isn't it? Now, this basically NIC card is having a address also. What address? The
MAC address,
MAC address. Correct. Right? What is MAC address?
device address.
Yeah. How do we explain if someone asks what is MAC address?
Basically, it's like a physical address of every device. Every device has a unique address, and it is like how many bits? Mm,
So it is a 48 bits
bit.
address, right?
Yeah.
It is a 48 bits address.
Yeah.
We call it hardware address or physical address, right? Or MAC address.
Yeah.
What it does? What is the use of this address? This address provides the unique identification to the device. It's a unique address, right? Device wise, okay, which will provide the unique identification to the device. Clear? So, and in this LAN adapter, we have an IC card, right? You see the chip. In this NIC, you will see this, what I said, 48 bits address, right? It is burnt in this particular NIC chip itself. Okay. That is why we call it hardware address. If you don't have an IC card, then where will you connect the LAN cable? Right? So in the routers and switches, we have LAN port. There we have very small NIC card, the LAN port, right? In computer, since it is a big, basically, there we have a whole NIC. If you take it out, you will get to know how big the NIC card is, isn't it? Inside of that, there would be so many chips and so many transistors, capacitors, and all those. Clear? The applications that we use basically, so you see here, every device, they are connected through the LAN cable, which is Ethernet cable, isn't it? Now, ultimately, this device is connected through this, and you see there's something written here. What is this? IP address. So ultimately, every device has a two types of address. One MAC address, one IP address. IP address is something, we have that MAC address and all. You see that, right? So this basically provides the unique identification to the device locally. When you say locally, what do you mean by locally? LAN, local area network within LAN, right? And when you say globally, when you say globally, what does that mean? Across the globe, WAN.
Yeah.
Right? And these are the commands you can check in PC. If you want to check what is my MAC address, what is computer MAC address, ipconfig in space and / all, it will give all the details. You see physical address, and that is how this MAC address looks like. Right? These commands are quite important actually to remember and to use day to day, because while troubleshooting, you would have to remember this. And similarly, you will also see the IP address 10, 10, 100, right? What is IP address? What is the length of IP address? 32 bit. So do you think any device which doesn't have MAC address as or IP address, or only has IP address but not the MAC address? Do you think? Or IP address alone will work, or MAC address? If we don't, if the PC doesn't have, let's say if this PC doesn't have MAC address, IP address, will it work? No,
No.
right? So ultimately both the addresses should be there, IP address as well as MAC address compulsory. Clear? Two addresses. These are some of the networking devices that you would be working on, that you would be configuring, you would be seeing, you would be connecting the cables and all. Router. What is router? Have you heard, like, uh, have you heard of this modem or router? See, these routers basically layer 3 device. Layer 3 means it works on the IP, completely IP. Right? So we'll discuss these equipments in detail, but as you see here, these routers can be, in scale a bigger kind of, because every device has its own platform, the model. So for small company, we have a small routers, which will be less costly. For the medium sized companies, you will have to go for the medium size of router, mid side of models. And then for the large companies where we have more number of users, you have the higher end, models, series of the routers. What it does, it basically connects to network. What is one network? Or when you say two network, what does that mean? We will discuss that. Okay. But as you see here, every device is having IP address 192.168.0 is compulsory, is a common in every device, right? This is one network. Okay. But if other device, which is this, let's say 82.10.250.19, so if these devices have to communicate with this IP address, what do you need? A router, right? Communication between two devices, router, two network in different, yeah. So router, basically we use it in the WAN. When we talk about the types of network, you see here, right? LAN, CAN, MAN. I won't actually go too much into it, considering you guys have little bit of idea, right? But wherever, yes, I think that is it is really required, I'll cover. So when we say types of network, what is LAN? This particular network, you see, is a LAN, local area network. Okay. Any, or I should say, this is a LAN, right? Okay. Any devices which are connected basically to the network. Let's say we have a building, right? And we have 5,000 user or 1,000 users in this building, first floor, second floor, third floor, fourth floor, like this. Okay. All the users, all machines which are connected to each other, it is a local area network. So no matter what all devices you have in this building, they all are connected through the, they all are network, LAN, local area network. Why? Because they all are connected through the LAN port. Through the LAN port. How the network would look like? If I see the logical topology, this is a switch, and then all machines would be connected. Could be laptop, could be desktop, could be server, could be printer, could be IP phone, anything. And they would be connected to the switch. Okay. And this switch finally would be connected to router. So inside of this building, that is how actually the network looks like. Right? You will have what? You'll have printers, you'll have servers. Also, you'll have access points. Access point for the wireless. Right? So that is LAN. Local area network connects network devices over a relatively short distance. Okay, over the LAN port. And you see over here, this is a switch. How many ports do you see here? 666 or 888? Right? Right? So 24. 24 ports are, that means this switch can connect 24 devices. Now, do you think, tell me one thing, if you have 1,000 machines, 1,000 user in one building, how many switches you need? So many, right? Even though if you are using so many switches, it is still a one LAN, isn't it? So I hope you guys are aware of, if I show here LAN topology, right, images. This all are, let me pick one, probably this. Maybe not this, but probably this. So this is one LAN in one location. This is different LAN in different location. This is other LAN in different location, right? A device is connecting. So you see how it is connected. A router, then we have switches, and then we have endpoints, all machines. Isn't it? All these work groups, right? That is how multiple switches are connected. Multiple switches are connected. See, in this building, we have engineering, production, we have finance and accounting, we have marketing and sales. These all are the end devices connect. Some of them are connected through the switch, wired network. Some of them are connected through the, this is a symbol of access point, through the wireless. And then all are connected through the router, and then router is connected to the firewall and then internet, right? So we have multiple segments wise. So this basically is one LAN. This is another LAN. This is another LAN, like this. Is it clear? So switch basically connects multiple devices. So what is the use? So can I say switch we are using in the LAN and router we are using in the WAN? Can we say this? Yes. Router is used in the WAN because it connects multiple network to network. Switch expands local area network, right, by connecting multiple machines, right? Or this switch can be, so most of you have heard about the OSI model, like we have layer 2, we have layer 3, we have layer 1. Layer 2, what is layer 2? Data link layer. The either switch can be a layer 2 or layer 3. We'll discuss about the OSI models and all. And then hub and bridge, we will not talk about this because these are very old. Now you won't even see hub and bridges, okay? So because bridge is replaced by hub is replaced by switch. But yes, for your knowledge, switch, hub, bridge, all we are using in the LAN. Clear? We'll keep on discussing about these devices in detail. So when we talk about the devices, obviously it is very important to talk about the cabling as well. What sort of cabling that we use, right? And how it is used. If I give you the cable, how would you identify whether it is what cable, where to connect it, right? So we network engineers, this fundamental is very important, isn't it? Because most of the time we network engineers is stuck in troubleshooting the physical layer itself, the cable issue itself, and we are unable to identify whether this is cable issue or some different issue, isn't it? So nowadays you would use either the Ethernet cable. When we say network cable, right, so it is all Ethernet cable, isn't it? And Ethernet cable means IEEE 802.1q standard. There are multiple standards actually, but I don't want to bombard with the so much knowledge from here and there, actually skipping the main topic. So I am not actually talking about all those standards and all that, just sticking to the main points. So when we say the cables, right, cables in the network, you will have Ethernet cable, okay, and then you will have also what, you see, optical fiber, or the fiber optic cables, right? Difference is, you see the port here, uh, in this switch, this port we have 24 ports, some different, and then these ports are somewhere some different ports. Do you see that 4 ports? Do they look like these ports? No. This is where the fiber optic cable you connect, okay, through SFP. Yes, the different module. So we'll talk about that again. But yes, Ethernet cable, in Ethernet we have fast Ethernet, we have gigabit Ethernet, we have 10 gigabit bit Ethernet, right? And each cable would have inside of that 8 cables, right? One Ethernet cable would internally inside how many layers? 8 cables, right? We call it twisted. Why? Because these cables are twisted each other with the different color code. You see the color coding also. Brown, white, brown, orange, then white, orange, green, white, green, blue, white, blue, right? Now, whenever you're building the cables, there are 2 types of cable. Ethernet I'm talking about, straight through cable and crossover cable. Let's take, guys, 5 minutes break and then we'll resume.
Same device.
Even though, yes, even though if you are using straight through cable for
Yeah.
to connect same layer device, it will detect automatically.
And then it will, how it will change? Because it has to change its behavior, right?
Yeah, these are very modular kind of approach.
Okay.
So the device automatically starts working accordingly.
Okay.
Okay, you don't have to really remember this, the color coding and all, but yes, you should know. You see that straight through cable. This is the straight through cable, right? So in a straight through cable, you might have seen this Ethernet cables and all, right? So you see the pin over here, right? These are the two end of the cable. This is one and this is the other, right? So you see this is straight through cable. This, if it is orange, so orange is other side as well. Whatever color coding here, it has to be other side. So this is side A, this is side B. Every cable you will have two connectors. One connector over here and one connector, this connector, RJ45 connector, right? How this RJ45 connector, isn't it? So you see this is straight through cable, all connects. So whatever color here we have, first pin, second, third, eighth pin. If we have white and orange, white and brown, they're also white brown, like this, straight through cable. Crossover, when you see, how you would identify whether it is straight through cable and crossover cable? By looking at the pin. If you see all pins are same in other end also, it's straight through. But in crossover, you see the first pin goes to third. So one side, first pin, which is white and orange, it would go to the other end, third pin, right? Second pin, which is orange, it will go to the sixth. First to third, second to rest, all 4, 5, 7 and 8 all are same. RJ45. So the cable, we use Ethernet. The connector is RJ45. Okay, this is how it looks like, the RJ45. This RJ45 you will connect on this port, right? So patch panel is nothing, but you will have further extensions to connect LAN ports. Okay. This CSU and DSU, these are basically whenever you get the connection from the internet, okay, you would, let's say you want internet access, right? From Airtel, for example, what you would do? You would contact Airtel saying, I want internet connection at my home. What they will do, near around they have a box, isn't it? Near around your location, they would have a box. In that box, with that box, we call it CSU, DSU, right? The cable which is coming from the internet, that would be CSU, and the cable which is coming from that box to your side it is DSU. So you don't have to, work on those. You don't work on those. You network engineers, either you will work on the LAN or WAN. But yes, overall you should know where it is placed, where do we connect. So if you think little logically, if ever you have taken the internet connection, you'll get to know that yes, I have taken. But it's not like they would take all the way line from the different location to and connect it here. No, they have already box, they have already ports available. They'll take one cable and connect to that box and give that connection to your home. Optical fiber, as I told, uh, under the sea, if you talk about how this entire world is connected, right? So under sea, what we have is this copper cable or the optical fiber optics. Now, if we talk about data transmission in this Ethernet, what is the data that is how it is transmitted? If it is Ethernet, how data is transmitted?
Electrical signals.
Ethernet bits,
Bit 0, 1, yeah.
right? Means 0 or 1, right? Fiber optic,
Optical signal.
electrical signal, because we have copper wire there, right? So whenever you are using Ethernet cable, you should know that, okay, it is transferring data in the form of bits 0 and 1. Whenever you have fiber optic cables, you should know that it is transferring through data in the form of electrical signal. Is it clear? So these things you have to make a note. Right? When you are making a notes, right? These things you have to make a note, because anyways you will get this slide. But what you won't get is this, whatever I'm saying extra, right? You have to make a note of it so that you can, whenever you're going through, right, revising it, these things it should automatically come in your mind as, yes, this is something we have discussed. I know what I have written. So making notes, again, it is very important. Why? Because after 3 years and 4 years, when after your first job, when you forget everything, you would like to still refer through your notes. And then trust me, I referred my notes, the CCNA notes, even after 4 years also, right? So you have to make it properly, because that is your language that you have noted it, isn't it? Not someone's language, and you would understand it very well. If you want to revise it, you have a day and you want to revise the whole course, you can still revise through your notes, because you have written in a way that will actually memorize everything, whatever you have gone through, before. So where, let me just put it here in the CSU. CSU, DSU and networking, and that to the image. You see, that is how it is kind of. And here we go. You see that from the WAN, the connection comes to the CSU, DSU, a box, and then from box, that connection will go to the home or maybe business or anything, anywhere. Does it make sense? Okay, fiber optic. Now just remember the connector that we use, that fiber optic, you can't terminate it in this RJ45. Okay, so for that, if you talk about now the connectors, let me put it here. Connectors. Okay, so in the connectors, what we have, RJ45, that connects what? Ethernet, right? And then you have also SFP, SFP plus plus, right? These are also connectors that connects actually fiber optic cable to LAN port. Okay, how does it look like, by the way, the SFP? You see that this is SFP. So one end will connect, and you see this is the fiber optic connector. So one end would connect to this fiber optic this way, and the other end would be RJ45. Okay,
So
fiber
basically, it
optic.
is fiber optic to Ethernet
Yeah,
Ethernet converter into 0 and 1 bits, right?
you see
Converts
that
electrical signals into 0 1.
this is fiber optic connecting to the SFP port, and then this SFP port will connect to the RJ45. Clear? Like this. Okay, coming back to this. So all those connections, what we talked about is LAN, local area network. The campus area network, the SCAN is basically, two building connection between two building. I'm not going to spend so much time in this. Metropolitan area network, where you have multiple cities in different locations, different cities, multiple building in different cities. Uh, Primarily, you would be working either in the LAN or WAN. So LAN and WAN is something important. Okay, all service providers, WAN network diagram. What do you see in WAN? Let me see.
Connecting to two different geographical locations.
Yeah, but what is there in the WAN actually? Again, it is mix of
Router.
routers. You see that this network, this is a WAN. This is different location. Then through routers, they would be connected to the different locations and all that. So normally in WAN, what you would see is the routers, right? Normally in the LAN, what you would see in what? Switches, access points, networking device. If we talk about, if we not talk about the end device and station, then switches, routers, switches, access points, wireless controller, right? Then we have wireless LAN. So wireless LAN, as I told you, if any laptop device wants to connect, this is laptop wireless, let's say, where will it connect to? Yeah, where will it connect to? This will connect to a access point. Where? Access point. This is a through the wireless signal, isn't it? If this device, if this is a desktop, it will connect to the switch, isn't it? Now access point and switch also would be connected. You might have seen here the network. When I say LAN network diagram, you see that this access point is connected to the switch. LAN cable is connecting to the access point, and this access point basically is giving the access to the or connecting all Wi-Fi devices through wireless.
So basically in house we have a like a wireless router, right? So we connect our phone to like Wi-Fi to our phone to that
At
route.
home, yeah, at home,
Yeah.
all devices like phones, they get
Mhm.
connected through the Wi-Fi, wireless.
So that is having an access point, it means.
Yeah, the device itself, right, in at home is an access point.
So router is a access point, and then they okay.
So it is access point come router, both. It has both the functionality, okay, because it also connects you LAN to WAN, isn't
Yeah.
it?
Yeah.
This is
Right. Right.
the connection goes to the internet.
Right. Right. So
So
it's
that the device which is there at your home, right, that is we call it modem,
okay.
where it has the access point functionality as well as the router
Route
functionality.
functionality.
Okay, these topologies are also somewhere it is important, though not that much, because no one would ask question, to be frank. Whatever we have discussed, if we talk about from interview perspective, what they would ask, this slide important, what is MAC address, what is IP address. Now you know the question, right? What is MAC address? You should be able to explain, okay, what is MAC address. What is IP address? You should be able to again explain, right? How to check MAC address in the PC? This is the command. How to check IP address in the PC? Command. Getting my point? And this is okay. What is a router? What is the difference between router and switch? Right? So switch is used in the LAN. It could be layer 2 or layer 3. A router connects two different network where the switch expands local area network. connecting multiple machines, isn't it? Cable part, no one would ask actually. This also no one asks nowadays. Topology also no one would ask. Even it is not there in the syllabus as well. Okay. Topology, what you have actually. But by the way, what topology that we would be working on? You see this, if in order to troubleshoot the network, okay, topology is important. How devices are connected, okay, that is important, right? So you see this in the LAN, we use a star topology. What do we use? This is a star topology. As you see, a centralized device. A centralized device could be what? Hub or switch. Let's replace this hub with a switch, and multiple end devices are connected to the switch. This becomes a star topology, right? Ring topology, there is no central device. All machines are connected to each other in the form of ring. What is the difference between this and this? If this cable uh, 1 second, if this cable is broken from here, what will happen?
All
Right?
devices stop working.
Won't be able to talk to each other. But if this device, if this cable is disconnected, they can still communicate. Yes or no?
Yeah.
This is the difference. That is why we don't use this, right? Similarly, you see the bus topology, just like ring, all devices are connected through the single wires. If this is broken, no one would be able to talk to each other, right? So hybrid is something good. Hybrid is kind of a mix of everything, other topologies, bus topology, star topology, wherever you need star topology, build a star topology, right? Mesh topology is also used because hybrid and mesh both are like combination of LAN topology and then WAN, LAN and WAN. Is it clear? So again, we are not talking about those devices, those topologies in detail, but just yes, to have a network fundamental knowledge, okay, to build kind of that foundation, strong foundation. I have mentioned it here that you should know the topology, at least how the devices are connected and how it should be connected. Tomorrow, if you are proposing some design, you should know how these devices are connected to. This is too early to discuss actually. We'll discuss by the way, but so before this OSI model, okay, we will also discuss this router and switch in detail. Switch. What is the use of switch? It expands LAN, right? So that is the main usage of the switch. What is the functionality of the switch? What is the functionality of the switch? Anyone? What is the functionality of the switch?
Communication between devices in the same topology.
Communication, okay.
Communication or data transfer, like it allows the devices within the same local area network to talk to each other.
Mm-hmm. Yes, pretty much.
And also it actually makes the decisions to like which data is supposed to go, like which device is actually communicating to which device. It makes those decisions and then it sends the data to that particular device.
We talk about how the devices communicate each other. Okay, like three-way of communication. What do you mean by three-way of communication? How devices talk to each other is what? Unicast, multicast, broadcast. What is unicast?
Point to point.
One-to-one
One to one.
communication is unicast. Multicast,
One to many.
one to many. If you have a 10 people, but if you are communicating with 5, that is multicast. If you are communicating with 1, that is unicast. Broadcast,
One to
1 to. If you are communicating with all 10 people together, that is broadcast. Okay. So switch basically, where does it work? In which layer?
2. And
Layer
3.
2. So since it is layer 2, can we say it understands what? MAC address.
MAC address.
Yes. Since it is a layer 2, we will discuss layers, by the way. It understands MAC address. Then switch is capable of all 3. What? It supports unicast, multicast, and broadcast. It supports all 3. Okay. When you say three-way of communication, three-way of transmission, types of transmission, how the data is transmitted. Simplex, right? Half, duplex, full duplex. This they ask question actually. This and this in interview. They might ask as a fresher, what is multicast? What is unicast? Right? You should know. And then what is half duplex? What is difference between half duplex and full duplex? What is simplex?
Just used for receiving or transmitting signal. Just one way.
One way, right? One way means
Either for transmission, either for receiving.
either sending or yes, transmitting.
For receiving.
Transmitting, I would say TX, or RX means receiving. Means either it can transmit the data or receive the data. Example, it's a keyboard. And monitor. Keyboard always sends the signal to whom? To processor. Monitor always displays the output. Right? Can you send the data from monitor to keyboard? No. Right? So keyboard is only meant for the sending it, and monitor is to receiving it. Half duplex,
Half to transmitting and half like to receiving
it
the.
can do both.
Yeah.
Right? Can do both, like TX and Rx, but at a time 1. At a time 1. Either it will, like walkie talkie. In walkie talkie, how we do? Right? What happens in walkie talkie? If you
One
want to,
speaks.
if you want to send the message, you have to press that button, and as soon as you are done sending, release it, then only you would receive it. 1 second, guys, someone has unmuted, and then okay, is it clear? Half duplex means both
Transmission. Yeah.
can be same time. Half duplex means both can be same time, sending and receiving, like mobile. Okay, so switch is a what? Full duplex. Switch supports full duplex, means it is all good, no collision, nothing, isn't it? Is it clear this much? So if someone asks what is switch, if you say this much, you answered it. Okay, is it clear? Now router, what does router do? Connects
Different.
to different network. I showed you the picture here, right? Over here. You see, this is router. So router is connecting LAN and WAN, isn't it? Router is connecting LAN and WAN. Router is layer 3 device. That means it basically forwards the packet based on the IP address. It also supports full duplex. It supports only unicast and multicast. Router never supports broadcast. Router never forwards broadcast. Okay. So that's router. So now you know the difference between switch and router. By looking wise also, physical appearance wise, let's say Cisco switch. You see how many ports are there in the switch? So many ports. Sometimes you would see 24 ports, sometimes you would see 48 ports, sometimes in fact you would see 96 ports as well, but mostly 24 and 48 ports. Okay, in this switch. But when we say router, do you have that many LAN ports? You
No.
see, do you have LAN ports in the router? How many LAN ports? 2 or 4 maximum, isn't it? 2 or 4 maximum, because it has multiple ports like serial ports. It has that empty port also where you can connect other, cables from which is coming from the WAN. So this is the only difference between switch and router. Sometimes when you go for the interview, right, they'll ask, okay, well, that device, do you see that? What do you think? What is it? When you go for interview, they'll ask like this: do you see that device at the corner? Which device it is? And if you have never seen this, the difference, randomly we'll say maybe switch or maybe, right? It's again important to know how router looks like, how switch looks like, how access point looks like, isn't it? Am I clear? Okay, very important, not only from the interview point of view, but from the overall understanding point of view also. If you have very good understanding in OSI model, okay, you can troubleshoot any network. Any type of network you can troubleshoot, right? What all, by the way, what all designations you get in the network before OSI model? What all designations you get in the network? Right? Network engineer, right? This network engineer can do multiple things like troubleshoot, which is ultimately support team, right? Support team. It can also monitor it, which is NOC team, right? It can design it, designing team. So there is a designing team. You can get any role, right? There is a designing team. There is an implementation team. In a company, I'm talking about, projects, right? So in a company, there would be a multiple actually hierarchy in networking. Few people actually would, would be there in designing. Their only job is to design the network, where we should connect, what router we should connect, how many switches we need, how switches are connected to each other, where access points are connected. All that is comes under the designing. Designing team would hand over that design to the implementation team. That okay, this is a design. Okay, you connect these devices together, and as per the design, connect everything together. Once the devices are connected to each other, then comes the and starts working, then comes this monitoring team, which consistently keeps on monitoring those devices. Is there any issue in your network? If you have any issue in your network, what will happen? This monitoring team will give it to support team. Can you troubleshoot? This is the issue. Can you fix the problem? Getting my point? So you can get any job as an in network engineer, right? Normally designing and Designing team is something very like experienced people, network engineers. But implementation, project monitoring, and troubleshoot, anyone can, even freshers also can. There would be a level of access. Okay, but these are the designations you would get. Network engineer, under network engineer, you may ask or you may be asked to do any of the role, right? So for everything, this OSI model is important. So you see here, there are 7 layers. Okay. And why OSI model actually? If we try to understand a bit of it, see, any technology that you study, you should ask this question yourself. What this technology does? What before this technology, what was the previous technology? Now, what is the difference between previous technology and this technology? How it is better than the previous technology, right? So if you know the purpose of any technology, okay, this technology like switch, if I ask you, why do we use switch? Just ask this yourself. If I don't have a switch in network, all devices would be connected to each other, which is not a good solution. So we have a switch. So switch is a central point where all machines are connected, isn't it? What was before switch? Before switch, we had a hub. Now, what is the difference between hub and switch? So that is how we learn the technology. That is how actually we try to understand the technology. See, when we talk about getting into the foundation or fundamentals, from making your fundamentals very strong, like these things you have to ask and do research. If you do more research, trust me, you would be very good in concepts. Keep on doing research, right? I mean, what is the difference between hub and switch? Trust me, if you just, we discussed little bit of hub and switch. Trust me, when you search this, okay, what is the difference between hub and switch? You would be having an idea about and proper understanding about the hub as well as switch. Okay, that is how switch works. What is the difference between switch and router? So you'll get to know, okay, that is how router works. That is how switch works. So that is why this, research is very important. Don't ever think that this 2 hours class would be enough for you to become a master. No one can become a master based on this 2 hours class. Okay, this 2 hours, think of that you are watching a movie where a trainer, me, I am talking consistently, and you guys are watching at me, looking at me, right? As soon as I stop talking or finish this presentation, 80% you will forget as soon as you reach home, right? And then when you come tomorrow, almost everything you will forget, because I am bombarding with the new topics, new discussions and all. Making sense? So what is the best way to keep in a touch with that previous lectures? Is the research. Study, ultimately, I should say. Isn't it? You'll keep studying, you'll keep, even though if you're in office, spare out 10 minutes, 15 minutes, 20 minutes and say, okay, we discuss router. Let me see in internet, how does router look like? What are the series of the routers? Right? What is the difference between switch and router? Isn't it? So that is how you would recall, automatically you will record everything, the 2 hour session that I have spoken here. You would recall all 2 hours. Okay, this is what the trainer spoke. Yeah, I can see this. This is what it is written. isn't it? Asking questions yourself. And if you are able to answer your question, that means you are good. You know the concept. But if you are unable to answer the question, then there itself you can judge yourself. You can judge your knowledge. Okay, ask questions. Couple of questions you ask yourself, right? Like think of, okay, what is switch? If you are able to explain, right, then you know it. And immediately you'll get to know whether you are able to explain it or not. So if you don't know how to explain or you don't know the answer, then what is the next? Immediately check what is switch. Okay. So I was talking about this OSI model and the origin of any technology. Okay. If you think yourself, why OSI model? What is this OSI model? What are these layers? What if you don't have? What if you don't have OSI model? What will happen? Right? So earlier days, what used to happen when we didn't have OSI model? I'm talking about before OSI model. Okay. I'll name maybe two companies, let's say IBM and HP. We all know IBM has its own product, HP has its own product. Yes or no? Now, whenever IBM used to manufacture its project, IBM has had its own style of manufacturing it, own rules, regulations, policies, isn't it? HP has its own rules, regulations, policies to manufacture their device. So now ultimately IBM device and HP device cannot talk to each other because IBM speaks different language, HP speaks different language, isn't it? So earlier that this is what the main problem was. Inter-vendor communication was not possible. This issue was raised to ISO, International Standard Organization. This is just an organization, just like we have WHO, World Health Organization, isn't it? Just an example. Similarly, we have ISO for the all internet issues, all like network issues related. So we have ISO. ISO has made a or announced one model which is called OSI and announced every vendor now onwards you all follow this OSI model whenever you're manufacturing your devices. You all follow this OSI model. Means you all follow these layers, 7 layers, right? And ultimately, yes, once they start following this OSI model, right, they were able to talk to each other because the same policies now every vendor is using, right? Same rules, same regulations. So OSI model, it is nothing but it explains actually how the communication happens between two machines, referencing the 7 layers, taking the reference of the 7 layers. Clear? Taking the reference of these 7 layers. So now you should know in detail what is the use of these 7 layers. Okay. What is the use of these 7 layers? So now you need to understand this layer by layer, one by one. Okay. So when you are at the sender end, let's say So let's say this device and this device, maybe a laptop. It doesn't look like laptop, but machine or anything. These two laptops want to talk to each other or wants to share the exchange the data. This guy has a data. Okay, or maybe this user is basically sitting here, okay, and wants to send the data to this user or email or anything. So this becomes sender and this becomes receiver. The one who sends the data becomes sender and the one who receives the data becomes receiver. In other word, the one who sends the data becomes source. What it becomes? Source. And the one who receives becomes destination. Right? Now let's say this user wants to send what? Or this user wants to access internet, for example. Okay. I'll put it this way because you guys use internet a lot. So let me put it like this. This is a Google server. Okay. And this user is connected through the internet. Obviously, if we talk about two devices, finally this user is connected to the internet and then internet to the Google. This is ISP. Okay. So obviously you are initiating the request, right? So you are sender and this is receiver or destination. Now to access a google.com, what do you need?
Web browser to type google.com.
What do you need?
So first we will
You
use,
need internet. Very
yeah,
good. You have internet connection. Then what do you need? Where will you type www.google.com?
in the web browser in your laptop, in our laptop. That is application where we will type google.com.
Where will you type? Yes, Shivani, you are correct.
Yeah. In the web.
I'm asking others actually.
Okay, sorry.
Yeah. So you would type it in the web browser, right? You would type it in the web browser. Examples of web browser: Firefox, Chrome. What else? If you have Mac, Safari, UC browser, now it is removed by the way.
Microsoft.
Opera and all, yeah. Microsoft Edge, Internet Explorer,
Yeah.
isn't it? Or these are web browser. Now tell me, if you don't have any web browser in your laptop, can you access internet? Can you access Google? No, right? That means you need it. So what are they? OSI model says this: application layer. we have application layer. Okay. What application layer is this? See, provides the interface to interact using various applications, enables user or software to get access to the network. Anything that you are doing in your machine to access anything or to use any service, you need application. If you don't have, and the one who has Android phone, if you don't have an Android software in your mobile, can you use your mobile? Can you use it? You got the brand new laptop, but no operating system. Can you use it?
No.
Yes or no? No. If you want to message someone, why someone is getting connected and disconnected? I don't know. If you want to text someone, you don't have text application or WhatsApp or Telegram or whatever you are using. Can you do that? No, right? So what you see on the screen, or let's say phone front view, front screen. Here we go. What you see on this screen, oops, what are these? These all are applications. Map, right? Everything here, these all are the applications, isn't it? So for everything you have a application. Getting my point? Without application, you can't do anything. So this is where OSI model says you should have application to, if you want to listen to a music, what application you need? MP3 file, right? If you don't have MP3 file in your laptop, straight away it will say this file cannot be opened. Why? Because there is no player, there is no application. What you will do? You will go and from the Play Store and all, you will download it, isn't it? So OSI model says the application layer is very important whenever you are interacting any software, you know, anything, browsers, Microsoft Office, operating system, Windows 7, 9, 8, 10, 11. These all are applications. Without that, you can't interact. Is it clear? Okay. So you accessed internet here, and you know that we know that for internet, what we use? HTML, isn't it? The language that we use here is what?
HTML.
HTTP, or HTTP is google.com or www.google.com and all that, right? So it's HTML based, isn't it? Request. Okay. Now, what if you are sending this HTML file and this Google doesn't recognize it what it is? Google thinks it is a song, it is a music, it is a any Excel file. For example, this machine sends one video file, okay? And other machine, how does it know that this is a video file? You getting my point? You sent a video file from here. How the other machine will get to know that this is a video file?
Suppose
You
it is
send a document, PDF file. How does that machine understand this is a PDF file? So this is the use of presentation layer here. Okay, the use of the presentation layer. Okay, I think this OSI model is lengthy topic, and I don't want to be in hurry as well. So let's cover this today. A lot of actually theory we have discussed. Okay. So that is the end of the session. We will continue with OSI model tomorrow. I have hopefully basic you guys are going ahead and try to understand the OSI model. We'll talk all from the practical scenario, will not get into too much of theory and all. Okay, but yes, that's it for today. We'll see you tomorrow then. Okay, any questions so far? You have a group, right? Any question you can always post in the group. I'm sure no one is going to do that. That is very common actually, but still. Okay, so all right then, that's it for today, and thank you for attending this session. Bye.
Thanks.